So, dear guys, welcome back to another new presentation on control system subject. Today, we will see about another very interesting and important topic of this control system subject. Today, I am going to explain you the type number of a control system. This is one of the very important topic. Okay, that's we will discuss today. By the way, today is the we'll see lecture number 35. Lecture number 35. Let us see type number of a control system. Type number of given control system. So sometimes in your gate examinations, even UPSC's IES examination, you will be asked what is the order of the system as well as what is the type number of given system. These are the two important bits, basically order of a system and then type number of a system. So basically, what is a type number of system? How the type number is identified for the given control system? Actually, it is very interesting and even it is very easy to identify. Our task is to identify the type number of a given control system. Okay, normally, as we have been discussing from our earlier lecturers or earlier presentations, if you refer. So the transfer function of any control system normally is given as C of S by R of S. C of S by R of S. If it is a closed loop control system or in closed loop control system, let us take either is it positive or negative feedback. So for negative feedback, G of S by 1 plus G of S into H of S if it is the negative feedback, and if it is the positive feedback, simply 1 minus G of S by H of S you will get. Here, if you see this G of S into H of S, this product means G of S into H of S. This product is called as loop gain. What? This is called loop gain of the system. Loop gain, or otherwise called loop transfer function, also called as loop transfer function. This product, what is that? G of S into H of S is called either loop gain or otherwise loop transfer function. So the type number, basically the type number is denoted by the type number of given control system is denoted by capital N, basically, remember. So it is denoted by capital N. The type number is denoted by capital N, and this N means the type number is identified or is observed from the loop transfer function. What is the loop transfer function? G of S into H of S. Okay, so in general for any given control system, the loop transfer function can be expressed as, in general, for any given control system, the loop transfer function means G of S into H of S. Nothing but this is what the loop transfer function or simply loop gain is expressed as simply it is some constant k into some p of s by q of s in general. So this is numerator polynomial, this is the denominator polynomial where k is some constant. Clear? P of s is some numerator polynomial, q of s is denominator polynomial. So p in terms of s and q is also in terms of s, and further this can also be represented as, or this can also be written as, so it is, you can write that s plus some z1, I will explain you this, s plus z2, s plus z3, and so on and so forth by this is s power n into s plus p1 into s plus p2 into s plus p3 into, and so on and so forth. Okay, means that, okay, this is what again your g of s into h of s. Clear? So k is constant here. So the numerator polynomial p of s furtherly represented as like this, s plus z1, s plus z2 into s plus z3. This is nothing but your p of s, as well as here this is what your q of s. This is what your q of s. So here s plus z1, s plus z2, s plus z3. S is in normal s, definitely it will come. This is the okay s domain basically. Whereas what is z1 here? Z1, Z2, Z3 are called as zeros. Z1 comma Z2 comma Z3 and so on and so forth. Z4, Z5, Z6 like that. These are called zeros. These are called zeros of the loop transfer function. Loop transfer function. I can write TF. So these are called zeros, means the roots, remember that, the roots of the numerator polynomial of the loop transfer function. The roots of this polynomial. Actually p of s is the polynomial, and furtherly this can be written as this like this, and this s1, I mean z1, z2, z3 are the roots, means s equal to minus z1. S is equal to minus z2, means that if you equate s plus z1 is equal to 0, s plus z2 is equal to 0, and then s plus z3 equal to 0, if you equate all these parameters which are there, factor, you will get s equal to minus z1. z1 is the 0. S equal to minus z2, that is also another 0. S equal to z3 is the another 0. The values of s of the numerator polynomials called as zeros of the loop transfer function. Similarly, if you from this denominator polynomial, so here p1, p2, p3, your okay, p1 and then p2 and p3 and so on and so forth. These are called poles. What? Poles of the loop transfer function. Of the loop transfer function. So P1, P2, P3 and P4, P5 like that, whatever it is there, they are called the poles basically, means those are nothing but the roots of the denominator polynomial. The roots, these are the values, nothing but these are the values of s. These are the values of s, means if you equate s plus p1 is equal to 0, then s is equal to minus p1. If you equate s plus p2 equal to 0, then s equal to minus p2. Means s equal to minus p1, s equal to minus p2, s equal to minus p3 and so on and so forth. All these s values, means minus p1, minus p2, minus p3 are called as the roots of the denominator polynomial, and these roots are called the poles of the loop transfer function. Clear? And then here if you see something s power n, so this n, whatever is there, this n is called, this n decides. What is this n? You know that this n is nothing but this n decides the type number of a system. The type number. So now it is given s power n, means that it is the type number is n here. Okay, s power n. N is the type number of the system. Okay. So now I will explain you one example so that you will understand. Okay, say for example, directly I will explain you one example. Say for example, so the loop transfer function is given as g of s into h of s by some 10 by s square into s plus 1 into s plus 2. Let us say this is the given transfer function, loop transfer function. Now tell me, what is the type number of this system? What is the type number of the system? So in order to identify the type number of the system, you need to observe the denominator part only. You are nothing to do with numerator polynomial. Forget about numerator. From that you will you will not get type number. So the type number will be estimated or will be identified from the denominator by observing the denominator polynomial only. So this is in the form of s power n denominator, s power n into some s plus p1 and s plus p2, is it not? So s power n form is there, means s square. So here your 2 is there, no? So your n is equal to 2, means that this is the type number, type 2 system. Type 2 system, this is called as type 2 system. So this given transfer function called as type 2 system. What is the type 2 system? That is what is the type number? Type number is 2. Likewise, and say I will explain you one more example. Say for example, so g of s into h of s is equal to s plus 1 into s plus 2 by some s plus 3 into s plus 4. Let us say this is general example I am explaining you. So g of s into h of s is equal to s plus 1 into s plus 2 by s plus 3 into s plus 4. This is the numerator polynomial p of s, and this is the denominator polynomial. If you, what is the type number of this system? What is the type number here? What is the type number here? So just you observe the denominator polynomial only. What is the value of n? If s power n is there or not, you have to see first. In the given problem, you need to see the denominator polynomial. In the denominator polynomial, if s power n is there or not. If s power n is there, then what is the value of n? Okay, so say for example, you have to compare this given with this s power n, basically s power n. So therefore here s power n form is not there. Assume that s power n is there. You assume that s power n is there, but however in the problem there is no s power n in general. So s power 1, s power 2, no s coefficient is given, s factor is not given. Means that what? So it is, then it is not given. But however, if you compare with s power n, then what is the value of n? If you substitute n value with 0, then what is s power 0? It is 1. Therefore, even though there is no s power n here, even though the s factor is not available here, that means that s power n is there, but the n value is 0. S for something power 0 is 1, therefore 1. Is it not? Therefore it is called, what is n value here then? N equal to 0. N equal to 0, therefore it is called type 0 system. Therefore this given system is called, type 0 system. Type 0 system. Type 0. Clear? Type 0 system. Okay. Likewise, say for example, another example. It is very easy to identify the type number. Say for example, another example, g of s into h of s into 10 by some s into s plus 1. Then tell me what is the type number? It is s power n. What is n value here? 1. So s power 1 is there, no? If nothing is there, it is s power n. Therefore s power n, what is the n value here? N equal to 1. Therefore, what is the type number of this system? It is a type 1 system. This is called a type 1 system. Type number 1. What is the type number of the system? Likewise, they will ask. Type number is 1. That is what the type number. Okay. So, simply you have to observe that the denominator polynomial, if s power n is there or not. If s power n is there, what is the value of n? That decides the type number basically. And normally, so one more important thing regarding this is, this n, whatever the n we are studying about, this n is nothing but, this n represents the number of poles that will be there at the origin of the loop transfer function. This gives the number of poles. This gives, what is the type number? N is the type number. Type number, what it describes, what it gives, the number of poles. The number of poles that are available at the origin of the loop transfer function. Loop transfer function. That is what. Therefore, that you must remember. That is very, very important point. So, the type number n, what n gives actually? The n gives that the number of poles available at the origin of the loop transfer function. That we will see in the next subsequent. What is origin? That we will see in the subsequent presentations. So, that is what the type number basically. Now, coming to the order of the system. What is the order of the system? What is the order? Order of the system means control system. What is the order of the system? Order of the system is also like your type number only, but here something, order of the system is nothing but, in general, say for example, for any second order system, what we have seen, the transfer function C of s by R of s is nothing but your transfer function. This is equal to, in general for second order, omega n square by s square plus 2 times zeta omega n into s plus omega n square. This is the standard form of the transfer function of any second order control system. This is the standard form of the transfer function of any second order control system. Okay. Here, what is the highest power of s? The highest power of s decides the order of the system. Therefore, what is the highest order? 2. Therefore, that's why it is called a second order system. Okay. I will explain you with an example so that you will understand better what is the order of the system. Say for example, directly I will explain you the example so that you will understand better. Say for example, so the transfer function. Okay. Say for example, C of s by R of s is equal to, no problem, you can write s plus 1 by s plus 2 by some s into s plus 1 and s plus 3. Let us say this is the given transfer function. Now tell me, what is the order of the system? What is the order? What is the order of this system? So here in this case also, you need to consider the denominator polynomial only. You must observe the denominator polynomial only. So here what you should do, you have to multiply all the product. Means here s is there, next s plus 1 is there, and then s plus 3 is there. 3 factors are there. Means so this s should be all must be multiplied. Therefore, s into s into s. Normally s cube will come. Therefore, the order is 3. The order is 3. It is a third order system. That is what the order means. S into multiplied with s plus 1. Definitely s square plus s will come now. And again s square plus s multiplied by s plus 3. What is the highest term of s? What is the highest order of the s you will get in this? Cube only. 3 s's are there. S into s into s cube. The highest order is 3. That is why that called the order of the system. Whereas if the, what is the type number of the system? Again, if type is to be considered, type is to be identified, then type is 1 here. because s power n value is 1, it is a type 1 system and the order of the system is 3. Sometimes likewise also they will ask some problem and find out what is the order and then type of the system, right, like that. So for order of the system you need to multiply all the denominator s factors and you identify what is the highest order. What is the highest order? That is the order of the order of the system. Clear? I will explain you one more example. Say for example C of s by R of s. It is 10 by. So s plus 1 into s plus 2. Let us say it is given like this. Now tell me what is the order of the system and what is the type of the system. What is the type? What is the type number? What is the order? Likewise, you will get in GATE as well as IAS examination questions. So they will give you control system. One problem they will give you like that. They will ask what is the type number? What is the order number for this? So type number, to find out the type number, you have to, for both these, you need to observe the denominator only. So for type number, s power n factor is there or not? So s power n is not there. If not there, write that type number is 0. That's all, straightforward. The type number, if s power n is not there, then if s power n is not there, even there should not be s even. You okay, directly s plus 1, s plus 2, s plus 3, like that. If they gives like that, the type number is 0, because here s power n is not given. Not given means n value is 0 here for s power n. So for if you substitute n value is 0, that is s power 0, that value is 1. Therefore 1 is there. Therefore that is called type number is 0. Then what is the order? For order, you need to multiply s plus 1 into s plus 2. You need to multiply these two, s plus 1 into s plus 2. S into 2 s's are there, s into s square. Therefore the highest order definitely it is 2. S square, no, you will get s square. The first term is s square. Not required to expand the complete expression, no, just s into s square. So what is that? 2. That is the order of the system. Clear? I think it is very interesting, no? So with this we will close today's presentation, and we will see the another interesting topic in the subsequent presentation. Okay, thank you and all.